So now let's look at an example. I'm going to say that a relation R is defined on Z by x relates to y if 11x minus 5y is even, and I want you to prove that R is an equivalence relation. All right, so I'm asked to prove that this relation is an equivalence relation, so we need to stop and remember, what do I need to show that this is an equivalence relation? There's three things. You need to show it's reflexive, symmetric, and transitive. So let's start with the reflexive part. So we kind of need to think about, why is this reflexive? So let's say I take an arbitrary element out of Z, and why is A related to itself? Well, if I want to say that A is related to itself, I need to say that 11A minus 5A is even. Well, we can simplify that down. 11A minus 5A is 6A is even. And why would 6A be even? To be even, you need to be able to write it as 2 times a number, 2 times an integer, and it's 2 times 3A. So 6A is definitely even. So now what we've done is kind of outlined the proof. So now let's write up the proof formally. Let A be in Z. Then 11A minus 5A equals 6A, which is equal to 2 times 3A. So now I'm going to let M equal 3A, since M is a product of integers. M is an integer. So what have we got? We've got that 11A minus 5A equals 2 times M, where M is an integer. So therefore I can say that 11A minus 5A is even, and A relates to A. Hence, R is reflexive. And I've proven that this relation is reflexive. So now let's show that it is symmetric. So let's think about this, right? Maybe even think in terms of an outline of the proof. We're going to assume that X is related to Y, or maybe I'll say, instead of X and Y, I'll go with A and B. A is related to B, right? That's the start of our proof. In the end, we need to say that B is related to A. Well, if A is related to B, that means 11A minus 5B is even. So 11A minus 5B is 2 times K for some K and Z. Now here's where we want to keep in mind what we're trying to go to, the end of our proof. I'll give myself a little bit more room here. is that B is related to A. So 11B minus 5A is even. So what I'm trying to work up to is this term down here. And so if you notice in what you presently have, your coefficient of B is not correct. So what I'm going to do is take what I'm trying to go to, 11B minus 5A, and I can write that as 11A minus 5B, which is what I have right here, plus, what can I write it? If these two sides are equal, then it would be negative 16A because then when I combine 11A and negative 16, I'll get negative 5A and a positive 16B, because if I look at negative 5B and positive 16, that'll get me 11B. Now we're going to plug in 11A minus 5B, that's 2 times K. And remember, my goal is to say that this number, that this 11B minus 5A is even. So it needs to be 2 times something, and it's 2 times K plus negative 8A plus 8B. And then I'm going to relabel this whole thing here as M. So this will be 2 times M. So now that I've got the outline of my proof together, let's write it up formally. So assume A is related to B, then 11A minus 5B is even. So 11A minus 5B equals 2 times K for some K and Z. Now we have 11B minus 5A equals 11A minus 5B plus negative 16A plus 16B. This is 2K minus 16A plus 16B, and we factored out a 2, K minus 8A plus 8B. And now I'm going to say let M equal K minus 8A plus 8B. M is an integer, since products and sums of integers are integers. Therefore, 11B minus 5A equals 2 times M, where M is an integer. This means that 11B minus 5A is even, and B relates to A. Hence, R is symmetric. Now the very last property we need to show is that R is transitive. So we're going to do an outline again for our proof. You start with A relates to B and B relates to C, and you need to conclude that the end of your proof will be that A relates to C. So what does it mean if A is related to C? You need to show that 11A minus 5C is even. So 11A minus 5C is 2 times a number. So I'm just going to hold off on that. If A relates to B, right, then 11A minus 5B is even. If B relates to C, then 11B minus 5C is even. So 11A minus 5B equals 2 times a number, so 2 times K. 11B minus 5C is 2 times M, another number. And right, what am I trying to get to? I'm trying to get down to here where I have 11A and I have 5C. If you notice in your equations, you have an 11A and a negative 5C. So maybe what we need to do is we need to add the equations together. So you're going to add these equations together. And if you do, you'll get 11A minus 5B plus 11B minus 5C equals 2K plus 2M. So I can take these middle two and combine my B. So 11A plus 6B minus 5C equals 2K plus 2M. And then I can move this 6B to the other side here. So I'll get 11A minus 5C equals 2K plus 2M minus 6B, which I can now factor out of 2 is K plus M minus 3B. So this shows that 11A minus 5C is even. So our last step is to write up the proof formally. So we follow our outline, assume A is related to B and B is related to C, then 11A minus 5B is even, and 11B minus 5C is even. Since 11A minus 5B is even, 11A minus 5B equals 2 times K for some K in Z. Since 11B minus 5C is even, 11B minus 5C equals 2 times M for some M and Z. Adding these equations together, we get 11A minus 5B plus 11B minus 5C equals 2K plus 2M. 11A plus 6B minus 5C equals 2K plus 2M. 11A minus 5C equals 2K plus 2M minus 6B, and 11A minus 5C equals 2K plus M minus 3B. Now we're going to let N equal K k plus m minus 3 times b. N is an integer, since products and sums of integers are integers. Therefore, 11a minus 5c equals 2 times n, and 11a minus 5c is even. Hence, A is related to C, and R is transitive. And we've proven now that since we showed that R is reflexive, symmetric, and transitive, R is an equivalence relation.